All right, folks, it's Bass Action, back in action here. In this video, we are going to look at these three different functions and determine if they are linear, quadratic, or neither. If the function turns out to be linear, we are going to actually write the equation for that line. When you are done with these three problems, there are 5 problems down below for you to practice this skill, and you will enter those answers into your online quiz. Let's jump into determining whether something is linear, quadratic, or neither. If the function is linear, it will have a common difference. That common difference is our slope that we are now going to also refer to as the rate of change. If the function is quadratic, it will have what we call a common second difference. We'll see this in a moment. So a common second difference, sorry about my handwriting there, and we will eventually refer to that as the rate of change of the rate of change. If neither of these apply, then the function is neither. That doesn't mean that the function doesn't have a rule that we could write. Just for our purposes today, we are only looking at linear versus quadratic, and anything else we will categorize as neither. So let's take a look at our first example here. We've got our x values across the top. We've got our y values, our f of x functions across the bottom here. And what we're going to do is we're just going to start comparing these y values. How do we get from the first to the second? We can see from -6 to 4, we're adding 10. From 4 to 14, we're adding 10. 10 to 24, we're adding 10, and so on. That pattern continues the whole time. So this function is linear. This 10 is our common difference that we would also call the slope, and we will also now call the rate of change. So because it has a common difference, this one is linear. Now, we should easily be able to write the equation for any line. So we're going to have our f of x. We just said that that common difference is our slope. We can write 10x. Now, we need to get to this y-intercept. Certainly, you could go through some of the process that you maybe did in Algebra 1 or Algebra 2, but we actually should be able to do this mentally, thinking about the fact that if this x value is 1, we need the first term of this function to be -6. If I put a 1 in here, I currently have a 10. I need it to be -6. So the pattern that we're going to find is whatever your f of 1 value is minus the slope will give you that y-intercept. So our f of 1 is a -6. We'll subtract our slope, so this should be a -16. So f of x minus 16 should, in fact, generate this sequence, and you can check it. Put a 1 into your function, 10 minus 16, it checks out. Put a 2 into the function, 20 minus 16 gives you 4, and so on. So you should easily be able to check that. The next one that we want to look at is this new pattern. Again, x is across the top, y is across the bottom. We're going to start checking for that common difference. From -6 to 7, I'm going up by 13. You might want to have a calculator handy. From 7 to 24, I'm going up by 17. 24 to 45, I'm going up by 21. If we continue, we'll see I'm going up by 25, up by 29, and kind of a messy 29, and up by 33. So we can see that this function does not have a common difference because these values are changing all the way along. If, however, we look at the difference of that common difference, we can now see that the difference between 13 and 17 is 4. The difference here is also 4, and 4, and 4, and 4. So we call this a common second difference. We will also eventually call this the rate of change of the rate of change. So this was the rate of change. And if we find the rate of change of the original rate of change, that's what this is describing, and it is consistent. So this function is quadratic. Now, there are certainly ways for us to get this rule, but that is not a concern for us right now. We just need to be able to write equations for lines and determine if something is quadratic. On our last one that we're going to do in the video, again, we're going to look for those common differences. I can see that I'm going up by 12, then I'm definitely going up by more than 12, and that's clearly not working, so it automatically is not linear. In fact, this one should jump out to us because if we find the ratio of 18 to 6, that ratio is 3. And then if I find the ratio of 54 to 18, it's also 3. So this one doesn't have a common difference. It does have a common ratio. Now, if you remember from your Algebra 2 days, this is actually going to be an exponential function. We will also call it a geometric sequence later. But for our purposes right now, we can just call it neither. So some things that you should certainly know, you should recognize this common ratio and know that that gets us to exponential. You may or may not have used the words geometric sequence before, but we'll get there. And then for us today, we just need neither.